In this video, we are going to study how to perform incremental rate of return analysis to choose the best alternative among given alternatives. So I have a problem here. I will read the problem first. We'll try to understand the key data that is provided in the problem, and then we will perform the incremental rate of return analysis. So let's read the problem. Company XYZ must purchase a machine recently destroyed by an accident. There are two options available. So we have two alternatives and we want to choose the best alternative among those two. The first alternative, machine A, it will cost $60,000 and it should last 20 years. Maintenance will cost $2,000 per year. So this option, we have an upfront initial cost of $60,000. The machine is going to last 20 years, and every year we have a maintenance cost of $2,000 per year, right? Then the next option, machine B, it is going to cost $72,000, so it is expensive, and the annual maintenance cost will be reduced to 500 per year. Again, this machine will also last 20 years, so it has initial cost higher, but annual maintenance cost is a lot lower. It's only $500 per year as compared to the $2,000 per year for machine A. So our goal is to determine the internal rate of return, or I would say incremental internal rate of return of purchasing machine B. If the company requires a return of 10%, this is also called as MARR, minimum attractive rate of return. I will write it down. MARR, minimum attractive rate of return. So the company requires a return of, or we can call it MARR, 10% on all its capital projects. Anything that gives below 10% rate of return, the company is not interested in investing in those projects, right? So with that information, which machine should they purchase? So let's see how we can solve this problem, how we can calculate the internal rate of return. So we can, first thing we need to do is write down the expression for net present worth for the each option. So for example, net present worth for machine A, that means we take all the cash flows that are happening in different years and bring them back to their present value, net present value. So we calculate that for A, and then we calculate net present worth for B. That is the first task we need to do. If there are more options, we could calculate net present worth for other options as well. So let's talk about machine A. So initial cost is $60,000. It is minus cost, and since it is already in its p value, means it's in current value, its present value, this is going to be spent upfront. So that is going to be added as it is, right? That's already present, and we are trying to calculate net present worth, and this component of that is already present, minus $60,000. Then we have $2,000 every year, so we need to find the present value of all those future cash flows, of $2,000 per year for 20 years, which is basically we indicate by letter A. That means there is annual cash flow, right? It's a uniform annual cash flow, which is given by letter A. Uh, so we know this A value, and we want to convert that A value, this series of cash flows, this series of uniform cash flows for 20 years, into its present value. So we know A, and we want to find out its equivalent P value. So that's why we need to multiply this number by the factor P given A. Find P given A, right? Find equivalent P. A is given. So P given A at I percent, which is the internal rate of return that we want to calculate. We don't know that. and at n. N is basically the number of pay periods or number of years in the context of this problem, right? So I will rewrite that here, minus 60,000 minus 2,000 times p given a factor at interest rate or internal rate of return that we don't know yet, and n is equal to 20. Now, same calculation for second choice or second alternative or machine B is NPW, net present worth of machine B. That is, initially we are going to spend $72,000, which is already in the present value form because it is upfront cost. So we don't need to multiply that by anything, right? So minus $72,000 minus, we have annual cash flow, annual maintenance cost negative because it is a cost, $500. And we have this $500 each year for 20 years. So that is a series of uniform cash flows. And we want to find the equivalent p value for that uniform cash flow series. So find p given a, we need to multiply this 500 by that factor at internal rate of return I%, we don't know, and n is same number of years, 20, which is again here 20. So I rewrote this thing here. So now we have NPWA, net present worth of option A, and net present worth of option B. So to find the incremental IRR of purchasing machine B, what we need to do is we need to equate these two net NPWA and NPWB. We need to equate them. So here is that formula or that expression. Net present worth of A is equal to net present worth of B, and then we can write these expressions instead of NPWA. So here is the left hand side, minus 60,000 minus 2,000 times P given A, and for NPWB we have this expression that we are going to write here, minus 72,000 minus 500, and that, right? Now we can rearrange the terms in this expression. For example, if we add $72,000 to both sides, right? Or I can rewrite it for you like this, just to make it easy. So I'm just gonna copy this first, Control C, Control V. So if I add $72,000 to both sides plus $72,000 to both sides, if I add to this side minus $72,000 plus $72,000 will become 0. And then we have this minus 500, these two, if I take this on this side, so for example this become plus the same thing, right? And then this side, if I add the same thing, it will become 0. So rearranging the terms in this equation, now minus 60,000 plus $72,000 is $12,000, and here we have this thing common, these parentheses are common, so we can take them out common, and 2000 plus minus 2000 here, minus 2000 plus 500 will be minus 1500 p, and then of course this common term here, p given a I% 20 is all equal to 0. Then we can further simplify this. We can only, because we want to find out interest rate, that is the only thing that we want to keep on the left hand side, and rearranging the rest of the terms, this 12,000, if we subtract 12,000 from both sides, it will be 0 here, and on right hand side it will be minus 12,000, and divided, then what we, so maybe I can rewrite this for you. So here I'm gonna add and subtract minus $12,000 from both sides, so this side will become 12,000 minus 12,000 will be 0, and this side will become minus 12,000, right? Then dividing both sides by minus 1500 will give us this expression. And then we simplify this, minus 12,000 divided by minus 1,500 is equal to 8. So now we know, maybe I can highlight this is important. So now we know that we still don't know the incremental rate of return, or I, but we know that at that particular rate of return, the value of the factor p given a is going to be 8. So that information I can rewrite at I percent interest rate or rate of return, p given a is equal to 8. So we can go to the compound interest tables and try to find uh, the I value for that value of p given a. So here are my compound interest tables, and let's start with, maybe we can start with 2% initially, right? Just as a, we have to start somewhere, so we can start at 2%. Okay, so here we are, and we need to look at row number 20. Why row number 20? Because we have n is equal to, or the number of pay periods or number of years in the problem, 20. So n here, we need to look at row number 20. And p given a column, we need to look at p given a column. This is present worth factor. Find p given a. Find p given a. That is 16.351. 16.351. But we want that value to be 8. So at 2%, we don't have 8, we have 16 point something, right? So it's not 2%. So maybe then I increase the interest rate. Maybe I go from 2% to, how about, less, and I'm just randomly going, right? You can continue to go, study each table and find out what p given a value you are getting. So for example, I will stop at 7%, right? Row number 20, and p given a is 10.594. Hopefully you can see that, 10.594. So once again, we need 8. We are going in the right direction, but still not there yet. So maybe I do 9% now. Okay, 9%. Row number 20, and p given a column is 9.129. So that's very close to 8. Maybe we will write it down. So here we are. I think 10% is even much more closer. So let's continue to investigate these tables. So 10%, row number 20, find p given a is 8.514. 8.514. Still not 8, but it's getting closer and closer. So I wrote it down here at 10%, p given a is 8.514. Okay, we continue to go. Now we don't have 11%, we have 12%. So okay, p given a 12%. Row number 20, 20 years. So we have 7.469. Okay, so this one was greater than 8 here, 8.514, and at 12% we have less than 8. So that means the interest rate should be between 10% and 12%, because the value of 8 is between 7.469 and here 8.514. So we write that down here, 12%. At 12% interest rate, or at 12% internal rate of return, p given a is, we found from the table, 7.469. So we really want to find I, and we know that it is between 10% and 12%. So how do we exactly find that value? So we know a point that is below it, and we know a point that is above it, right? So we can use a mathematical process of interpolation uh, to find that I. So how does the process of interpolation work? So here I will explain to you. So Maybe we can just rearrange these so it's just makes a put it in the middle because it is in the middle, right? Like that. Okay. So what we do is we have 3 points basically. If we consider these as your uh, x0, y0, x1, y1, x2, y2. So what you need to do is x1 minus x0 divided by x2 minus x1. Uh, or in this case, I percent minus. So on the left hand side, in the process of interpolation, you can write I percent minus 10% here, I minus 10 divided by 12% minus 10%, x2 minus x0, 12% minus 10%. It may seem complicated, but all you have to do is arrange them in the sequential order and then do the I minus 10 divided by 12 minus 10 on the left hand side. It can be any numbers. For different problems they can be different numbers, but the middle number minus the first number divided by the last number minus the first number. So we get the left hand side like that, right? uh, x1 minus x0 divided by x2 minus x0. And on the right hand side we write down the corresponding these p given a values or y. So if this is x1 minus x0, this should be y1 minus y0. If this is x2 minus x0, this should be y2 minus y0. So corresponding y's. So for I percent, we know that corresponding y or corresponding p given a is 8. For 10%, we have corresponding p given a 8.514. So we do that 8 minus 8.514 divided by, for 12, the corresponding p given a is 7.469. So we write that down. For 10% again, it is 8.514. So we write that down. So we simplify this side. That's going to give us this answer here, 0.4919. We also simplify this side. Actually, uh, I mean, it's if we simplify this equation, all we need to do is keep I on the left hand side, right? So for example, uh, here uh, I minus 10 divided by 12 minus 10. So let me see if I can do it on a open a calculator. So just make it as simple for you. Okay, so let's me uh, do this. Let's first do the right hand side, right? So we have parentheses. We have, I don't know whether you can see this calculator or not. Maybe I make it bigger. You will be able to see it now. Okay, so in the parentheses we have 8 minus 8.514 divided by parentheses 7.469 minus 8.514, and we close the parentheses, right? So that's going to give us this 0.4919 if we short form is, and this should be actually I minus 10 divided by 12 minus 10, which is 2. Then if you multiply both sides by 2, the 2 will disappear from the left hand side and we need to multiply right hand side by 2. So multiplied by 2, that's going to give us 0.9837. That is I minus 10. So I is equal to, if you add 10 to both sides, I is equal to 10 plus 0.9837. So 10.9837%. So that's our final answer. So let's see. Maybe I highlight it again. So this is the incremental rate of return with the answer that we wanted to find out. Uh, Determine the IRR of purchasing machine B. Now, what does that tell us? Which machine should we choose? So here is how you make that decision. So now that you have rate of return, you compare that rate of return with the minimum attractive rate of return that is required, 10%, right? So if your rate of return is higher than the minimum attractive rate of return, then you go with the initially higher, initially option that is initially more expensive, or initial cost of the option is more, that option you should go with. So in this case, that means machine B has a initially higher cost. So that is the option we choose. We choose machine B. In case if your I is less than MARR, less than minimum attractive rate of return of 10%. So say for example your answer was 9 point something, right? So if that is the case, if your incremental rate of return is less than the MARR, then you should go with lower cost, lower initial cost alternative. In that case, you should have gone with machine A. So that's how you can make that decision. That's how you can choose the better alternative. So the bottom line, what we learned in this video is, uh, if two alternatives are given, first write the expressions for their net present worth for both the options, then equate them so that you can find the incremental rate of return. And once you find the incremental rate of return, you compare that with minimum attractive rate of return, and based on that you make the appropriate decision about which alternative should be chosen. So I will stop here. Thank you.